All right. Good morning, Golden Bears. My name is Ricky Vides. I'm your Equity and Department Advisor in Mechanical Engineering in the Student Service Office. Welcome to the #1 public university in the entire universe. I'm excited to start this chapter in our university's history. In the upcoming days, please take time to reflect and embrace what it means to enter our institution at this particular stage in your life. As the years pass, the gift of time will remain relevant as you all notably observe your individual and your collective growth. When I entered Berkeley, I believed the myth that the next couple of years would be the last few years that I would spend in the classroom. However, I firmly believe that by the time you graduate, what remains permanent is your pursuit of lifelong learning. What I enjoy most about working with everybody is our global presence and our global reach. Berkeley really is a global platform. In our department, you are part of a community that represents 80 cities and towns across California, 6 states across the union, and 36 countries from around the world. And just to name a few, there's folks in the audience that are from Australia, Brazil, Colombia, Canada, China, Egypt, Germany, France, Nepal, Taiwan, Thailand, and Vietnam, and much, much more. Wherever you are in the world, I know that you will continue to contribute your time and energy, and as a department, we're grateful for the many contributions that you will make. Yes, all the legends are true. We're an incredible university. We train the best students in the world, and in our department, that training starts today, on day 1. We're here to train engineers to rise up, to facilitate measurable growth in our society, and respond to the needs of the future. However, we're only great because of the students that are in our audience. While our department facilitates instruction and provides guidance throughout, it is everyone in this room who challenges us to perform at the best possible level on a daily basis. And beyond the contributions that you will make in our department, you will engage with the community and share your expertise beyond our boundaries, which is something that I'm really proud of. Before all that, you'll spend many, many hours in this hallway, which is Hesse Hall, which will become your second home. And you might start to feel like you're a squirrel that's hanging for your dear life at some point, with success just towering over you, wishing you can go back to the days where life was a little bit more simple. You got to play with these. In all the complexities that you'll be engaging with, you'll be able to play with these. And in between, of course, you'll get to have some fun. It's all part of the transformation. You might be shy now, you might feel a little out of place, but discovery and exploration implies transcendence. It's exciting to go beyond what you know. It's nice to travel into new dimensions, to build your skill set, your competence. This is all really exciting. Here's an opportunity for you to learn something every single day, either about yourself or about the world. And soon you'll be able to activate some support from the community, get some backup, get by with a little help from your friends, form your inner beast, sharpen your claws, and stand tall. When this is all over, here's where it all will go down. Long nights, bright days, and shining your light on all of us. So let there be light and go Bears. If you need to get a hold of us, we're at me.berkeley.edu, where you'll have access to all our contact information. I want to introduce the Dream Team. We have an exciting program for everyone. And it's an honor for me to be able to share this great lineup of speakers and presenters with you all. We have the Director of Student Services, Carolyn Clark, our Chair, Dr. Roberto Horowitz, our Vice Chair of Equity, Grace OConnell, our Vice Chair of Instruction, Dr. Karrie, and Dr. Hayden Taylor will be delivering a course demo. We also have folks from the machine shop who will be sharing their expertise and offering a virtual tour. So without further ado, I will introduce Carolyn Clark, who will take the stage.
Hi, everyone. Good morning, good afternoon, good evening, whatever time it is, wherever you might be, welcome to the Department of Mechanical Engineering. Despite what's happening around us in the world and in our state, we are still so excited that you have decided to join us this fall. Congratulations on all your hard work and effort to get here, and we are so happy to have you here and your families in some cases. I have to say I witnessed the university and our entire mechanical engineering community putting in heroic efforts to maintain the quality of the student educational experience last spring. And we know that our plans for the fall will help make this coming semester a memorable quality experience as well. I also know that you're in very good hands with our undergraduate and staff equity advisor, Vicki Vivas. Please don't hesitate to call on us or your ESS advisor with any questions that you have. And I look forward to meeting you all on campus as soon as possible, hopefully in person soon. And now I have the honor of introducing our illustrious department chair, a triple bear himself, Professor Roberto Horowitz.
Thank you, Carolyn. Hello, everybody. My name is Roberto Horowitz, and I am a professor in the areas of control and autonomous systems and robotics, and the chair of the department. Normally, I would spend my 5 minutes of fame telling you about my own 45+ year uninterrupted experience at Berkeley, starting as an entering sophomore, more or less the same as just some of you, in mechanical engineering, and culminating so far as the department chair. However, we are currently living in extraordinary circumstances. You're the first in which most of you have not only graduated through a virtual online commencement, but you will be entering and attending your first semester at Berkeley also in a mostly virtual online manner because of the terrible pandemic that has engulfed the world in general and our country in particular. As if this was not enough, the state of California, and particularly our Bay Area community, is also currently confronting unprecedented challenges because of the horrific wildfires that are currently accosting us. Thus, the current challenges of having to simultaneously confront both the invisible threat of the coronavirus while living, working, and studying under the very real safety threats posed by the wildfires should be a strong reminder that now, more than ever, our society depends on a new generation of highly trained and thoroughly educated engineers that will lead us with clear and imaginative ideas and innovations into a more sustainable, robust, inclusive, equitable, and yes, prosperous future. We believe that you will find Berkeley in general, and our department in particular, to be an absolutely invigorating and stimulating environment in which to carry out the next phases of your educations and to prepare you to confront these challenges and many other challenges that lie ahead. One thing that I can assure you about Berkeley is that you will never be bored, and you will always have many avenues to explore and challenge yourself. So please choose wisely and conservatively on what you to get involved in, particularly during your first semester, so that you have the opportunity to explore our wonderfully diverse, fast-paced, and stimulating environment. We're always here to help you. Thank you. And now I'm going to introduce our very capable and my good friend, Karrie, who is the Vice Chair of Instruction. I think you're muted.
Software, I'm still getting used to the control here. So, okay, well, let me just say hello to everyone and welcome you, all our new students, into the ME program. I am the Vice Chair of Instruction for the Mechanical Engineering Department, and I work with the staff in our Student Affairs Office to help coordinate the instructional programs in the ME department. As I think Ricky was mentioning, you probably know that you're entering one of the top mechanical engineering programs in the country. Our undergraduate program is currently ranked #2 in the nation, just behind MIT. And that may seem a little daunting, but I want to assure you all that if you are here, it's because we believe you have what it takes to be successful in our program. We're committed as a staff and a faculty to creating an environment that helps all our students be successful here. So please try to take full advantage of the resources as you navigate your way through the program. I'm going to actually take a counterposition to what Professor Horowitz said. I see Berkeley as a very stimulating place, and I'm going to enthusiastically recommend that you take full advantage of that. The fact is that there's a lot of opportunities here on campus, both within the mechanical engineering department and the campus as a whole, to explore a wide variety of different areas and issues and challenges. Ricky already mentioned that there's a number of student groups that do things working on special projects like the solar car team and the super mileage team. There's also groups that get involved in a variety of different activities connected to engineering. The student section of the American Society of Mechanical Engineers and the Society of Women Engineers. And there's also the Berkeley Nanotechnology Club. So there's lots of things outside of the classroom that you can engage in. And these are opportunities to explore new areas and give your chance to experience some of what's going on at the cutting edges of these technologies. I also want to mention that one of the great things, at least in my opinion, about being at Berkeley is that just about every department on campus is among the best in their field. And you have the opportunity to take classes with top instructors and students in those fields when you take electives in all these different areas. This gives Berkeley a tremendous level of intellectual energy and makes Berkeley a place that offers special opportunities for personal and professional growth. So I'd encourage you to take advantage of some of those opportunities. And if you have questions or concerns, please do reach out to faculty and staff, particularly in our Student Affairs Office. We're eager to try to help students if they're encountering difficulties or just have questions about how to proceed. And I'll close then by wishing you all the best in your academic work here at Berkeley. And I'll cheer you on, as we commonly do for all our students, by saying, "Go Bears." And I guess I'm handing off the microphone here to our Vice Chair for Equity and Inclusion, Grace O'Connell.
Hi, welcome everybody. It's really exciting to see a new cohort of students, even though it is virtual. I hope we'll be able to meet in person one day soon. So I'm the Vice Chair of Equity and Inclusion, and my research area is actually more in medicine, biomechanics. So I look at why and how the soft tissues in our body fail with age and with disease. And it's also a personal interest of mine, as I'm also an athlete and experience a lot of soft tissue injuries. At Berkeley here, we want to really see you succeed and all students to succeed. And I work very closely with Ricky. We're here to provide those sources of information that Professor Karrie mentioned earlier, and to encourage all students to become involved in outreach activities. Berkeley is well known for its community engagement and community involvement, both at the undergraduate and graduate level. Students get involved at teaching at local schools when we used to have in-person classes, so hopefully by next semester, next year, we'll be able to do that again. But we're also here as a resource for you in case you're experiencing any type of additional stresses that keep you from being able to succeed in your classes. And this year is a particularly unique year in California, as mentioned earlier, with the COVID-19 pandemic and being in California with the wildfires. It seems like everything is coming all at once and we need to be dynamic and flexible. We will provide resources, for example, the Berkeley Basic Needs Living Document. And what that means is it will be updated whenever there's additional resources, whether it's technology, food, so on and so forth. But if there's something that's not on that resource document, feel free to reach out to myself or to the Student Services staff, Ricky. I just wanted to highlight some of those student groups that were already mentioned and where you can find some of these student groups. So in a given year, we have tabling where student organizations can actually meet with you, but most of you are probably virtual this semester. So if you go to the ME website, you can see a long list of ME-related student groups. Some of these are engineering-based technical student groups. Others are affinity groups. For example, the Society of Women Engineers, HES is for Latinx students, OSTEM is for LGBTQ, and BESA is for Black engineering scientists. And then ASME is just the general overall student organization. These are great organizations to join for peer mentorship and just a sense of community. And that the peer mentorship and study group aspect of things will be particularly important as you're starting your college career, for those of you in your first year, online, because study groups are a great way to quickly learn, because the material tends to be very fast here at Berkeley. And then as you start to go through your college experience here, looking at what are your next steps, how do I apply my mechanical engineering degree out in the real world to get a job, we have community spotlight articles on the ME website. So feel free to peruse through there and look at what various alumni have done with their mechanical engineering degree, what type of jobs exist. There's also faculty spotlight articles. For example, Professor Goldner started last year, and he moved here last year, and he does a lot of fire research, which is very applicable for California. So welcome and go Bears. And I think at this time, we're going to pause for a few questions, if there are any questions from the previous presentations. If not, I can present or introduce Professor Hayden Taylor.
How do they ask questions? Can they just step in and talk, or?
They can put it in the chat, I believe.
They can put it in the chat?
Mm-hmm.
So, no. We have a lot of, we have 87 participants.
You can also navigate to the top right and ask to ask your question by asking to present. So if you want to share your screen, you can ask your question, and everybody in the audience can use that function.
We were very clear.
No, so there's no way of, Zoom has a way of doing hands and things like that. No way of doing polls unless.
Well, if there's no questions, I can introduce Professor Taylor. Does that sound good, Ricky?
Yeah, that's great. Actually, there was one question. You want to take that, Dr. Connell?
Sure. What are some ways to go more in depth on specific pathways within mechanical engineering? One of the ways to do that is through the technical elective courses that you'll take your junior and senior year. I believe it's 15 credits worth of courses that are required for the degree program. So that's a good way. Things like ocean engineering, take a class in ocean engineering, aerospace engineering, biomechanics, and we have a long list of options there. Another way is to get involved in academic research, and the most common way of doing that is to reach out to various faculty that are doing research in an area that you think you might be interested in. That way you can get more hands-on experience. Or the last one I would say is student groups, student organizations. A lot of students will join student groups like CalSol, and they actually get hands-on experience through that. So there are multiple different pathways that you could go through.
There's another one here. When is the aerospace major coming to Berkeley? We're not sure yet. We're working on it, and by we, I mean the College of Engineering, but I'm happy to report that our department has just started a minor in aerospace engineering, and it's starting this year. So we're going to have a series of courses that you can take, 3 courses, one in aerodynamics, another one in composite material, and another one is in UAV control, that will allow you to get a certified minor in aerospace engineering. We've been working very hard and diligently on setting up a major mechanical engineering department, but it's now going to be taken to the College of Engineering, and I think during the next semester we will have a plan to when we expect within 1 or 2 years we will have a major in aerospace.
Now, maybe I'll just
Go ahead,
add that if you're entering as a freshman, there's a high probability that the major will be in place in time for you to participate in that later in your program.
Right.
If you're entering as a JC transfer, it's not clear whether that'll be the case, but the minor is in place now, and students can begin participating in that even at this point in time.
Okay, so there's another question here. It says, how do you know which prof is doing research? I would say most of the professors in the department are doing research. So the way to find out is look at the website and look throughout what areas. And I have to confess, my website is not the best one in the world, so you won't get that much of an idea of what my current research is, but some people do have a very good website. Also, you can also visit us cybernetically, set up an appointment and chat with us. But I would say the department has areas of expertise, and at least the professors that are working in those areas. And I would look and explore their website, also their publication list. There's more questions.
And to get to the individual websites, you can go through the me.berkeley.edu website. I included a link in the chat.
That's correct.
That shows by area.
So there's another question. Well, a lot of questions now. Let's see. What attributes?
So the next question was, what skills do faculty look for in research labs, to hire for research labs? And I would say that varies very much from one professor to another. And so when you're looking for research opportunities, don't be afraid of rejection or not getting a response. If you don't get a response, that has nothing to do with your application. It just means that our emails are a mess and we have a hard time finding emails. So just keep at it. Just keep emailing and trying to get in touch.
The skills, it depends on the area, as Grace said, but I would say most important skill is enthusiasm and willingness to work hard. And of course, we will also be looking for, make sure that you can embark on the research. So sometimes you need to have taken some courses like programming, some math courses, etc. But we're always looking for young, talented minds to shape and to work with. So it's the favorite job of all of us, I think, is to do research with our students.
I'd also like to
I think
well, Dr. Caleb.
Go ahead.
So I'd also like to add that our curriculum is structured in a way that you start to develop skills pretty early on. So for example, a lot of our students will take E7 during their first year. They'll take a data science course by the time they're done with their 4th semester. And all the combination of those skills of being able to program, being able to have some exposure to data science, and also engaging with computer-aided design tends to open up opportunities for students to be strong researchers. So just keep in mind that our curriculum does support being able to gain those research opportunities, if not in our department, in other departments as well. So I definitely encourage everyone to set up meetings with faculty. Look out for weekly emails that I send out that have announcements around different research opportunities. Faculty will send me different announcements to share out with the community. And also there's different opportunities. I heard somebody mention URAP, which is that stands for Undergraduate Research Apprentice Program. And we often combine forces with URAP, which is an LNS program, to allow students to do research through them while being supported by one of our labs.
So there's a short question here. Can students who are not in mechanical engineering do the aero minor? And the answer is yes, you can, as long as you have taken the prerequisites or equivalent. So yeah, we're not restricting the minor just to mechanical engineering students. In fact, we would want to have as many outside students as we can.
Alexander and Dylan ask questions that are related to internships and getting closer to industry. One thing that I'll comment on, in addition to career fairs, student organizations will have info sessions by various industry members. So keep an eye out for that, because that would be advertised through the newsletter sent out by Ricky as well.
Right. So there's one here that says, I don't know, as a mechanical engineer, would you all advise to take the Fundamentals of Engineering exam, EIT? What kind of boost does it gives you? What industry requires it? If yes, when would you recommend taking it? I don't know the answer of that. Does anyone?
Well, I can comment on that a little bit. I actually have taken the EIT, and the approach in my case was simply that it was easy to take immediately after I had finished my bachelor's degree, because you had already mastered all the fundamentals and it was an easy exam to take and pass. It is a pathway to a professional engineering license, and there are certain areas of engineering practice where that is valuable. If you work for a consulting firm, or you work on government projects where having a professional license is an important credential, that can be beneficial. Civil engineers often get this type of credential because it supports construction type projects. Mechanical engineers, I don't think it's as much as of much importance, because most companies don't really see that as being a tremendous advantage. If you leave Berkeley with a BS in mechanical engineering, most of the companies in California and across the U.S. will recognize your level of technical expertise as high, and I don't think you would gain a lot by doing the EIT. Can't hurt. It's easy to do right after you graduate if you want to do it, but it probably isn't really horribly necessary for most applications.
Okay. There's another question that says, how often should mechanical engineering students undertake internships?
I'd say the frequency that I see it is every summer. Usually students will engage in an internship. However, it does vary. Some students will do a mixture of, like, one summer they'll do research, the next summer they'll do internships. Quite often, students will do this. They'll engage with internships over the summer, like I mentioned. However, there are co-op opportunities. So certain industries will recruit you to actually leave school for a semester and be part of their industry full time. And that's called a co-op. So if you hear that term, that's what it means. But I think in terms of getting an internship, having like 2 or 3 under your belt by the time you hit the market is usually a good way to go.
Yeah, I strongly recommend it. I took one when I was a Berkeley student. I ended up going all the way to my home country in Venezuela and working on an oil refinery, and it was really, really interesting. So I would say, particularly if it's a good company and it's a good opportunity, I think, and in the summer is a very valuable experience. Let's see. There's more question. I saw on Facebook that EECS has an internship fair coming up on Handshake. Will there be one soon for mechanical engineering as well? Ricky, you know, we're setting something up like that.
So right now we're working on a career fair, which has a lot of that same flavor. It's not specifically an internship fair. However, a lot of the industry that we do invite are either looking to hire students full-time once they graduate or recruit them for summer internships. So it's in the works, and we're hoping that we can have one planned out by the end of September. So stay tuned.
Okay, here's a one that I think is going to elicit several responses. It says here, how many clubs or research opportunities do you think is manageable to deal with as a junior transfer? So I already told you what I thought. Van says, I don't know. I think it's. I think my feeling is, I advise students to be conservative. First, make sure that you're handling your courses well, so, and don't get too much over your head. On the other hand, I think it's a very good, you know, they're wonderful. We have some wonderful groups like the mileage, the racing team. So it's, you got to play it by ear a little bit. It's particularly the one thing that you're going to find is that Berkeley is more challenging than your typical junior college. So if you were doing great in your junior college and, you know, you had ample time to spare, then by all means. Otherwise, be a little bit conservative at the beginning, but then plunge in. I think it's one of the great experiences of Berkeley. I don't know if, Van, you want to add something to that or not?
I think I would just add one comment, and that is that, you know, these activities kind of, you know, break down into two groups. You know, the clubs that work on high mileage vehicle and solar car and human powered vehicle, you know, those give you a little bit more of an engineering experience. You know, the focus is on designing and building and performance testing. If you're really see yourself pursuing an engineering career and that's the type of activity you like, then certainly, you know, I would encourage you to go for something like that. If you think you want to go on to graduate school and do more high tech related stuff, that might make more sense to focus on some sort of a undergraduate research activity, because that would give you an opportunity to see what research at the graduate level is like and get a sense, you know, if you like it and what areas of activity you're most interested in, and that will help prepare you for some decisions about whether you want to go to graduate school.
So I guess I'll add my comment and address the question about the minor. What I would suggest is just keep in mind that time is a non-renewable resource, right? You have a limited amount of time. And depending on what your own personal goals are, may decide how many clubs you're interested in and what type of clubs you're interested in being in, because your GPA doesn't define you. So if you participate in more hands-on activity clubs and you get really involved in that, that may impact your performance in your classes, but you also pick up skills. So these are all personal decisions that you'll have to make and weigh the balance on all of those.
Lucero asked a question about when should we start looking for internships and what is the process like for it. I'd say that probably hiring cycles for companies tend to be in mid to late September for hiring folks that are going to be graduating that May. However, for internships, I'd say there's a window for summer internships generally between January and the end of February that are the most highly recruited. That's the most highly recruited season. However, I would say keep looking at beyond February. There's different things happen at different companies. There might be a gap that might need to be filled, and you might be able to fill that gap. So definitely stay engaged with companies that you've had contacts with at career fairs and just check in with them, because the internship cycle is sometimes relative.
So I was pointed out that I skipped one question from Lucero. So let me mention. Let me read the question. Would you recommend doing a minor?
We just took care of it, Dr. Roberto.
Oh, you just took care of it?
Yeah.
Oh, okay. There we go. Okay, sorry. So what's the next? Oh, does COE have the faculty mentoring program? The answer is yes. Somebody here is looking way ahead, but anyway, so we do mentor our faculty. When we have our junior faculty assistant professors, they all get assigned to one or two mentors from who normally are more senior faculty to advise them on the do's and don'ts. And also the college, both the campus and the college actually offer quite a bit of advice and courses, much more than they used to offer when I came in. I don't know if anybody, Grace, you have any comments on that? On the faculty mentoring?
That it's helpful.
Yeah, you got some good mentors, I know that.
Yes.
Anyway, okay.
Official mentors and non-official mentors.
Yeah, that's right. Official and non-official.
I wonder if the
another
question was about faculty mentoring students.
I don't know. It says here the faculty.
I can answer that question. So there are, we do assign every incoming student with a faculty advisor, and we do update that list around registration time. A lot of our faculty will be aware of the different requirements. However, I advise you to really reach out to myself and the ESS advisors for different curriculum matters. But what we do is we do set it up around that time period in case that's intersecting with your goals. So once you have an assigned faculty member, definitely touch base with them, send them an email, and try to find a time to connect with them so that you could have some connection to our department. And they might not be the best person for you initially, but they'll be able to connect you with the next person. So the whole goal is just for you to have some exposure to faculty by assigning our students to faculty mentors.
Yeah, and they would be good to talk to about specific questions like minors and minors for you and what your goals are, or what other classes you should take. For example, maybe you want to teach taking classes in education or in business. That's what your faculty mentor or your ESS mentors are there for.
So I just want to make a comment that we need to move the program along a little bit more so that we can cover some of the other elements that we want to present during the program. However, I can answer 2 more questions and then move on to Dr. Taylor's presentation. So I'm going to answer, let's see. I'll check the last 2 that were asked. So as someone who's potentially looking to pursue an MBA, maybe in the future, would you think that taking those technical electives would be better than pursuing a full MBA degree?
And I could just
Go ahead.
I was just going to respond to Jesse's question about internships and international students. My observation has been that many of the companies, at least in the Bay Area and Silicon Valley, tend to be fairly open-minded about attracting international students into internships. So I would say that the chances of an opportunity there are reasonably good, if you make the right connection. So it may not necessarily be a barrier.
And I would also say our Berkeley International office is a good resource, and I'll add that in the chat as well.
So in terms of the question about business administration and economics, we do offer some technical electives that can be taken in that area. However, we are pretty restricted in terms of our technical electives. So 9 out of the 15 units have to be ME sponsored, which really does limit your choices to be able to extend beyond that. You could take some courses in economics for fun on top of our pretty heavy curriculum. However, if you're interested in pursuing an MBA, one way that I think that you can consider that is taking a decal through UGBA, which is our undergraduate business administration program. There's a lot of opportunities there. There's also opportunities for you to collaborate and do either different design projects or offer some of your engineering skills to the projects that they're working on. So there's a lot of cross-disciplinary opportunities that I think could feed your entrepreneurial spirit. So just keep that in mind. It's not entirely convenient to intersecting it with our curriculum. However, there are extracurricular opportunities. So we'll transition now to Dr. Taylor, who's going to offer us a course demo. And I'd like to ask the other presenters to, you can either leave, which I think would be better, because Dr. Taylor would have the floor to himself now that your presentations are over, or you, at minimum, I think you should minus your screen.
Bye-bye.
Okay.
Welcome.
Bye, everyone. Okay.
Bye-bye.
Right. Great. Well, so would you still like me to finish by 12 or?
You can go on a little further if you need to, Dr. Taylor.
Okay, cool. I'll try to not take too long. So yeah, I'm going to talk to you today about a couple of things. One is to share with you some of my how I got to Berkeley, how I ended up here, and I think that's relevant because it's definitely informed some of the things that I work on now in my research. And then I'll show you some of the work that we've been doing with a new form of 3D printing that can create three-dimensional objects very rapidly and generates all points in the object simultaneously. So I'm from the UK originally, as you may possibly be able to tell. I was an undergraduate in Cambridge. And then when I was a junior, I had the opportunity to actually come to the US and do a year-long exchange at MIT, which was actually the first time I'd been to the States, the first time I'd actually been on an aeroplane. So it was a big adventure and really reshaped my life in a couple of ways, because while I was there, I did do undergraduate research in a lab that looked at semiconductor manufacturing processes and some of the sources of variation that cause semiconductors not to yield perfectly when they're manufactured. So I worked on that and in fact loved it so much that once I got back to the UK, I decided I would apply to come back to the States and do my PhD here, which I duly did, in fact, in the same research group. So I then spent 5 years in Boston working on my PhD, and in the course of that, actually, I made quite a few trips to Singapore. We had a sponsored research project with a couple of universities in Singapore, all about manufacturing microfluidic devices. In other words, labs on chip that can do diagnostic tests in seconds. And we were trying to look at how you would manufacture these in their millions once they really came on stream. So I went there, and then at the end of my PhD, became very interested in how I could use actually optics inside microfluidic devices. So I then moved to Singapore and I did a postdoctoral stint, a couple of years there, working on this new idea. It was a big departure, leaving Boston. Something that I sometimes wondered whether I'd made the right decision to move into a radically different research topic. And actually, while I was there, I was on the faculty at the Technological University there, NTU, and there actually met a faculty member from Berkeley who then introduced me to the department, and I ended up getting hired here. Been here since 2014, and love teaching and research and all the other things that happen here. So the reason I told you all that is that the path has definitely seemed quite circuitous at times. One thing has seemed to lead naturally to another, but there have definitely been times when I've wondered whether I was making the optimal decision. But all of the things that I've done, semiconductor manufacturing, microfluidics, optics, they've all played into the research that I do now. And I think it's because I've had a range of experiences that my research is what it is. So I would say, if things don't seem linear or logical at any given moment, that's not necessarily a problem. So actually, my degrees or my majors were electrical and electronic engineering, but my undergraduate degree was very broad. So we did do mechanics and materials and thermofluids and so forth. So I had quite a range of course experiences, and that was also useful because during my PhD I got into a research problem called nano imprint lithography. So as you are probably well aware, semiconductors are transistors are getting smaller, faster, cheaper all the time, and actually probably one of the two biggest challenges that the semiconductor industry faces today is physically creating such small sub 10 nanometer features. Usually it's done with projected patterns of light. Diffraction is now really the limiter on that. And so there is a school of thought that you should move to a mechanical way of doing it, where you create a stamp that has these 10 nanometer features on it, and you use it to physically deform a layer of polymer material to create those shapes, which can then be transferred to the silicon underneath. And it's a radical departure. For it to work, it really relies on a lot of mechanical engineering theory, contact mechanics, elasticity, and so forth. And so that problem became interesting to me because I had the double E coursework. I'd worked for a semiconductor manufacturer designing memories, and I also had some of the mechanical coursework, and so the intersection was what was interesting to me. And similarly, some of the signal processing courses that I had taken actually became really important when we started working on the tomographic printing process I'll describe in a moment. So Ricky wanted me to say a few words about some of the courses that I teach here, and so I teach predominantly manufacturing, and what I've done for quite a few years here is teach a class called Intro to Manufacturing, or Engineering 27. We're actually going to segue into a new class in the spring, which I will be teaching the first iteration of, called E29. And we're actually integrating our Intro to Manufacturing class more with the graphical communication. We're going to call it Manufacturing and Design Communication. But a lot of the principles will remain the same. And I think one thing that distinguishes Berkeley's curriculum from some others is that we are not just trying to inform you about what is out there in the world of engineering today. We certainly do that. We study how various manufacturing processes work and the physical principles behind them and so forth. We're not just trying to do that. We are also trying to encourage you to develop ways of analyzing, critically appraising, and possibly also inventing new ways of doing things in my field, processing material, creating new manufacturing processes that may be more energy efficient, use less raw material, use raw materials that are more available, and so forth. And so I think it's that sort of framework for analyzing things that we really try to emphasize. So for example, in Engineering 27, soon to be 29, when we look at 3D printing or additive manufacturing processes, rather than just go through a list of different processes, powder fusion, fused deposition modeling, stereolithography, we kind of break it apart into the functions that have to be performed. So we say, okay, well, any additive process has to somehow supply material in a way that can be reformed or reshaped. In other words, it might come in a powder, it might come in filaments, it might come in sheets, it might come as a liquid, and various different materials could come in those forms. We have to supply energy to the material to transform it into the final object. We might do that with light, we might do it with heat, we might do it with some other form of energy, like electromagnetic radiation in non-visible ranges. So there are all sorts of ways we could deliver the energy to transform the material. And then you've got to have a way of controlling the shape. Do you do that with a scanning mirror that deflects a laser beam across a powder bed? Do you do it with bead screws, linear actuators? Do you do it with some other form of actuation? And the reason we try to break apart these different functions and then reconstitute them in the class, is that there may well be combinations of solutions for these functions that no one has thought of before. that could be combined in new ways to make for more effective manufacturing processes. And actually, that is one of the things that we try to do in my research group. We try to invent manufacturing processes that use less material or energy and help with both the economy and the climate in various ways. So I'm just going to share with you for a few minutes a piece of work that we have been doing over the last few years. And this is now, okay, I think it should work. Right. Okay. So this is a new way of 3D printing. Now, pretty much any 3D printing process that you will come across today isn't really 3D. And what I mean by that is that you build up the object through a long sequence of lower dimensional unit processes. For example, if you are doing fused deposition modeling, you are extruding molten polymer out through a tiny nozzle, and you have to draw out a bead of polymer to create one layer at a time. Or if it's laser sintering of metal powders, very often you're scanning a point of light across the surface to locally melt. And so it's slow. You have to worry about the thermal characteristics of that process, what thermal gradients and therefore stress gradients will be built up in the manufactured part. There are some processes that have a one-dimensional unit process where, for example, you are squirting a row of droplets of liquid onto the part at any given moment. The Hewlett-Packard multi-jet fusion printers are an example of that. Object printers. These are printing resins that will solidify once they've been jetted onto the surface. So the ability to produce multi-material parts, but also rather slower than it could be. And then you've got 2D unit processes where you create one layer of an object at a time. And this is very often referred to as stereolithography or digital light printing. And if you've come across the company Carbon or Carbon 3D, they make very fast stereolithography systems. What they're doing is they're shining up a pattern of light from a video projector up through a tray of resin and solidifying a microscopically thin layer of material one at a time. So that's faster than 0D or 1D, but it's still slow, and you still get directionality in the mechanical properties of the objects that are produced to some degree. So for a while, people have been thinking, well, could you actually do a truly 3D process where you create the whole 3D object at once? And one approach to that is to do what's called holography, where you create a three-dimensional field of light by interfering many beams coming in from different angles. And because light has a specific wavelength and you can control the relative phase of many different rays of light, you can get them to interfere and create a 3D pattern of light. And if you're printing into a photosensitive material where that light is brighter, you're going to get solidification. So this seems like a thing that's worth pursuing. A lot of people are pursuing it. We looked at it for a while. The trouble with this is that it's much easier to get high spatial resolution within the plane of the projector, in other words, from left to right in this sketch, than it is in the direction the light is propagating. So it's hard to get high resolution in all dimensions. The second problem with it is that because you're relying on phase and interference between different beams, it's very, very sensitive to tiny aberrations in the refractive index of that material. One of the problems is, as you solidify a photopolymer, its refractive index actually goes up slightly. So you're actually introducing scattering and errors as you print. So what if you could do it without relying on phase, just relying on intensity? And one thing that you could do is beam in different patterns of light from 3 orthogonal angles, X, Y, and Z, and where those patterns of light intersected, they would be brighter just by adding together the intensities of the light, and you'd be able to solidify material. So that's a great idea. It could be very quick, but it's quite geometrically limiting because you can only solidify where those beams actually intersect. You're limited to basically quite symmetrical objects. So we then thought, well, can we make a more general approach that is all about superimposing intensity? And we looked at computed tomography, which is an imaging technique that's used very, very widely in engineering inspection, in medicine. You know, you go to the hospital and get a CT scan. They beam X-rays through the body from many, many different angles, capture an image of what is transmitted, and use software to reconstruct with an algorithm what actually lies inside the body. So we thought, let's flip that principle on its head and create objects tomographically rather than imaging them. So we have now a rotating container of a light-sensitive liquid, like a photopolymer, and we have a light projector, just a normal video projector, that is shining in a constantly evolving pattern of light from the side. And so as the object rotates, the pattern is changing, and over time, the total dose of light, the total number of photons that any given point in that volume receives, can be controlled independently in X, Y, and Z. Where that dose exceeds a threshold, you can get solidification. So we call this process computed axial lithography, or CAL for short. And here's a short video that explains how it works. So let's say you want to print this, this thinker statue. You take your CAD model, your STL file, you would look at it from many, many different angles in software and create what are called projections through that. You then have to do some manipulation of those, some optimization, but after that, you string them together into a video, you play it back into this rotating vat of light-sensitive material. It's important to note that this has the rays have to go through it, getting very gently absorbed as they do so. And so over time, you're synthesizing this dose of photons, but every point in the object is receiving light at any given moment, which is crucial for being able to form the part simultaneously. Once it's formed, you can drain off the resin and post-process it. So here are some very early videos that we made of the process working, and the light is coming in from the side. And the yellow container is the photosensitive material. It's sped up a little bit, and you'll see that over time, actually, you're not seeing much, but right at the end of the process, you start to see the image changing. And that's because the refractive index is going up, as I mentioned. It's starting to scatter light back into the camera so that you can see it. So this is probably the biggest object that we've printed so far. It's a dental model. And here are some examples of components that we can print. We can print complex geometries that are not in any way symmetrical. We can print lattices that have internal voids. So even though the light is beaming through the volume, you're not actually having to solidify everything inside. You can print objects within objects. You can print suspended structures without actually having to have removable support material. And as anyone who has worked with other 3D printing processes may know, very often you have to put in temporary support and break it away later. Well, with us, the liquid is the support. We can use really high viscosity resins that provide that support during printing. We can print into really soft materials like hydrogels, which can potentially be really valuable for tissue engineering applications in the future. And really, the apparatus that we use for this is pretty simple. It's one axis of rotation. It's an off-the-shelf video projector, maybe an extra lens, but it's not difficult to make the apparatus. The materials are mixed from off-the-shelf components. Where the sophistication really lies is in the computation. So we are trying to take a CAD model of a part, slice it, and then figure out what should the projected video pattern be. And I don't really have time to go into this much, but we're using something called the radon transform, which is widely used in computed tomography imaging. But we have to add some sophistication on top of that for the following reason. In computed tomography, it's fine if there's no restriction on whether the signal that you're capturing needs to be positive or negative. But in projecting light, you can't have a negative intensity. So whatever pattern we design in our video that gets projected in, it has to be either zero intensity or finite positive intensity. And actually, a lot of the work that we do now is trying to come up with better algorithms that will take the raw output of the radon transform and refine it so that when you project back the light with this constraint that it has to be positive intensity, you can actually get close to the desired geometry. This is an example of what you have just immediately after the radon is applied, and this is after some optimization. Things have sharpened up. You get a much sharper transition of dose. We're working a lot right now on printing very soft materials, printing these hydrogels. We care about that because creating artificial vasculature systems, networks of blood vessels with a wide range of length scales is really important. And they have to be very, very soft. So Young's moduli down to maybe 100 Pascal in some types of tissue. So this is something where our process potentially comes into its own because of the constant support that the resin gives you. Okay, I'm going to actually just stop sharing my screen and just make a few more remarks before I finish. I realize I've gone 10 after, so I'll try and wrap up fairly rapidly. So I saw there are a lot of great questions about how to find good research opportunities and how many different research and extracurricular things to do. And I think most students grapple with this, and that I certainly did as a student. I did a lot of theatre, actually designing theatre and doing production of theatre, and that is almost an unbounded time sink if you let it be. So I'm well acquainted with the challenges of managing time. I would say, obviously, I'm just one of about 40 or more faculty in our department. Almost all of us are doing research most of the time. So I would really encourage you to just go and connect with either people you're taking classes with or people whose research papers or websites look interesting to you. I would second the comment about persevering. I'm afraid my email inbox is always overflowing. So even though I would love to be really prompt and to the lab, who wanted to be in the lab, sometimes it's things slip through the cracks. So definitely persevere. And as to sort of how to balance whether to do lots of different things or whether to sort of focus on a limited number, I think that there are arguments both ways. And honestly, I would say one of the nicest things about doing undergraduate research is that it helps you to gauge whether graduate school is something you would enjoy. And so there's a world of difference, of course, between doing well in coursework where the objectives are well defined and the knowledge is defined, versus research where the whole point is we don't know what the outcome is going to be. We are trying to be the first people in the world to figure something out. So that sort of uncertainty or the need to be charting a path with colleagues is something that can be really unsettling at first, and it takes a little while to get used to it and embrace it. So I would say give yourself the opportunity to embrace it, and that may mean doing multiple stints in different labs. You probably want to see, do you want to do more computational work? As with Cal, we do a lot of algorithm development, but we also do a lot of experimentation in the lab. So different people like doing different things. And that will ultimately inform which labs you may want to do graduate work in, if that's what you do end up doing, or what industrial position you seek. So I would say enough to get a cross section, but also it is worth sticking with something, I would say, to the point where you can prove a contribution. And what's really nice is if you can somehow get your name onto a conference paper or a journal paper that the lab you're in is producing. And if you go and work there, work with a grad student, contribute, show up, that's totally doable, I think. So I would say having that marker there that I was in a lab, I contributed, and here's what I have got to show for it. That is really potentially quite valuable when it comes to graduate school applications and so on. So I hope that that is helpful to people. And some people may not be aware that research doesn't have to be on a volunteer basis. A lot of it is, but a lot of it is also paid off grants that people have. And also you can get credit. There are various course numbers for independent studies centered around research. So I hope that has been somewhat helpful. Ricky, is there anything else you'd like me to say?
Thank you, Dr. Taylor, for giving us a great presentation. Right now, we're going to be transitioning into a virtual tour of the machine shop. But I think we have time for 1 or 2 questions. So if anybody has 1 or 2 questions, feel free to ask them in the chat. Someone wrote, isn't this basically still 2D where you're just rotating instead of translating?
No, because you are constantly able to expose every point in the volume, even though the intensity that is being seen at any given point may be fluctuating over time. Every point can be getting exposed over time. And that's important because actually one of the main things that limits the throughput of a 2D photopolymer process, where you're lifting the object out of a tray, is the hydrodynamic effect. So think you're actually printing a fine layer of material, then you've got to lift it up, and actually in doing that, you've got to draw in liquids to replace fill the gap that's being created. The resin has a finite viscosity. If you're printing a wide, thin component, that will take time. So it's that's the big departure. That the object you're printing, every point is getting exposed simultaneously, and you don't have relative motion of the object relative to the liquid while you're printing. So you can actually use a wider range of materials, much more viscous materials, or even things that are gels at the time they're being printed. Does the process necessarily rely on using visibly transparent materials? Good question. That was one of the questions that the reviewers asked us, as you might imagine. So it has to be reasonably transparent to the light that you are using to initiate the solidification reaction. And that wavelength, we work with a lot of different wavelengths, everything from long wavelength UV, sort of 365, 375 nanometers, through blue to even green. And you want it to be absorbent enough that the process takes place at a reasonable rate, because you've got to get the photons absorbed to trigger the chemical reaction, but not so absorbent that it all gets absorbed near the edge. And actually, we think that the process is at its fastest when about 1/e of the intensity is absorbed by the time you get to the middle of the vat. So if you wanted to make things that were visibly opaque, you could do that with some constraints. If you put a dye in that is not going to absorb at the illuminating wavelength, and we did that actually with a dye called Crystal Violet, which looks purple. So it transmits really well at UV and blue, but absorbs at longer wavelengths, and so you can sort of play off the illumination and then the appearance of it.
All right. Well, thank you, Dr. Taylor. I really appreciate your willingness to join us during GBO, and I'm sure all the students look forward to meeting with you in the spring. Go Bears. Cool.
Yeah, I look forward to it too.
All right.
Okay. Oh, one more question. Sorry, they keep coming. Can't the dye be put in later? Not that easily, because once you've solidified it, the diffusivity of materials goes right down. You could certainly put coatings on. One thing we thought about is, could you kind of precipitate little nanocrystals after you printed to turn it from transparent to opaque, but we haven't been able to do that yet. Okay. Okay, I don't want to take up the entire afternoon.
That's okay. We'll take the last one.
Yeah. Okay, Leah. Okay, this last one, and if you can email me actually hkt@Berkeley if you have other questions. But do you have an indication as to whether the photoactive materials are suitable for human tissue? I mean, photopolymers and their biocompatibility has been a huge field of study for a long time. There are plenty of photoinitiators that have been proven biocompatible. We actually, when we started doing this work, we actually focused on something called camphor quinone, which is used in the dental space. It's sensitive to blue light, which is preferred because you don't have to sort of shine UV into people's mouths. So that's definitely a huge area of research, and we're taking advantage of what has been done.
All right.
Okay.
Thank you so much. And we'll be transitioning to a virtual tour of the machine shop, followed by an introduction from our machine shop specialist. Thank you, Dr. Taylor.
Hello, and welcome to the Mechanical Engineering Student Access Machine Shop. My name is Jacob, and I'm one of 5 technical staff members that work here in the student shop. Today, I'm going to take you on a tour of the shop and show you some of the equipment that students have access to. But first, I'd like to describe what it is that we do here. The Student Access Machine Shop provides students with a unique hands-on learning experience that helps bridge the gap between the theoretical and practical worlds of engineering. Here, students learn about machinery that's commonly used in present-day manufacturing. This experience helps students better understand the abilities and limitations of various manufacturing techniques and ultimately makes them better designers and engineers. Students can get access to the Student Machine Shop by belonging to one of the 3 following university-based organizations: class, research, and pre-approved extracurricular team-based projects. Students belonging to any one of these 3 organizations can receive full access to the shop after completing our comprehensive shop training course. The hands-on portion of the training covers the basic fundamentals for operation of most machines in the shop, including belt sanders, bandsaws, drill presses, engine lathes, and milling machines. At the end of the training, students are asked to reproduce this part. The 3D printers, the machine begins printing a 3D model at the very bottom and works its way up 1 layer at a time until the entire print is completed. The process for 3D printing begins with the development of a CAD file or computer-aided design file. From there, the CAD file is imported into 3D printing software where it is graphically sliced horizontally and a toolpath is generated for each layer. The toolpath specifies the motion of the printer and instructs the machine where to displace material. Once the CAD file has been sliced and a toolpath has been generated for each layer, the code is then loaded onto the 3D printers and the machines can begin printing the object. 3D printing is an excellent resource for rapid prototyping. Students are able to design a component and then produce a 3-dimensional object in a matter of a few hours. This allows them to test the form and fit of a component and really get a sense of how it interacts with other components. Oftentimes, a design will have pitfalls that the designer could not have anticipated until having the physical part in front of them. However, because of the relative speed and ease of 3D printing, students can make design changes to their CAD files and reprint the component within only a matter of a few hours and can continue this process until they are fully satisfied with the object's functionality. Once they have finalized a design for a component, they can then proceed with manufacturing that component out of a more durable material on another machine. A CNC machine, or computer numerical control, is a machine whose movements and commands are executed by a central computer control. This is a CNC milling machine. Milling machines are equipped with a rotating spindle where a cutting tool is stationed. As a workpiece is fed into that rotating cutter, it removes material. The movements of the workpiece along the X and the Y axis, as well as the movement of the spindle along the Z axis, are controlled by this central controller. Additionally, the rotational speed of the spindle, how quickly the workpiece is fed into the cutter, tool changes, and much more are also controlled by this controller. The control, and in turn the movements of the machine, is driven by a conversational programming language called G-code. G-code is an alphabetical and numerical-based programming language that tells the machine to execute a command, where to execute it, and how quickly to execute it. It can repeat these commands efficiently, repeatedly, and accurately. This makes the machine highly useful in large-scale manufacturing applications where thousands of parts need to be made daily, and each of those parts needs to be identical. Here is a sample part that we'll be cutting in our demonstration. I'd like to point out that once I start the program At no point in time during the cutting process will I have to intervene or interact with the machine. CNC machines are meant to automate many of the manually based manufacturing processes previously used, ultimately increasing efficiency, quality control, and productivity. I'd also like to point out the tool changing system on this machine. This machine is equipped with a 20-station tool changing carousel. This means that up to 20 different tools can be loaded into the machine and used to cut a wide variety of features on a part. The machine will swap out the current tool in the spindle for a different one at a specified point in the program.
All right. I want to bring Scott to the stage, who are our machine shop specialist, who will be able to answer any questions that you might have.
So for those that missed it earlier, I provided a link to the page where you can actually see the video. You shouldn't have the lag and sort of audio that we were experiencing here. I'll just go ahead and post that up in the chat again if you missed it. Yeah.
Scott, do you want to introduce yourself and let all the folks know how much experience you have?
Sure. Pardon my getup, but I'm actually I'm on campus, so trying to follow all proper safety protocols. My name's Scott McCormick. I'm the manager for the technical staff for the Department of Mechanical Engineering. So that includes the Student Access Machine Shop, which Jacob is one of my colleagues. There's also 2 other technical staff that work in the student shop full time. Under normal circumstances, you would be signing up with us for a safety orientation for the student shop, which takes approximately about 5 hours, and which time you get a lot of hands-on experience. It's the student shop is about 5,600 square feet. We have a wide array of both traditional machine tools as far as kind of unconventional machining processes. I would say that modestly, we are one of the premier student shops in the world. You won't find anything that's probably better equipped than what we've currently got. Unfortunately, right now we're not getting you in here, but I'm hoping that in the near future this pandemic gets resolved and we can welcome people back into the shop. The other side of the technical staff is we do support all the instructional laboratories for mechanical engineering. So there's a lot of upper class, what we call hands-on laboratories, either mechatronics or various different engineering based laboratories where you get to actually get involved with either testing equipment or testing materials or building a project of your own design. So I think that's with that. I'm gonna pass this on to Jacob, and thank you very much, and looking forward to seeing everybody here soon.
So there's a couple of questions that came up in the chat. William asked, do we have to have training on every machine to use any of them? So basically the way that our shop training works, and this is also highlighted in the video, so I'd recommend you go and check this out just for your own sort of future reference. But the way that our shop training works is it's a comprehensive shop training course. It's not sort of like cherry pick which machines you want to end up using. So our shop training course, as Scott had mentioned, is 5 hours, and it's sort of a comprehensive, every single machine in the shop. We'll show you the basics on how to use a belt sander, drill press, bandsaw, engine lathe, and then a milling machine. There's, of course, some accessory machines that go along with it. But basically, in order to use the facilities, in order to come into the facilities, you need to have that shop training done. And you'll make a widget, like this little sort of like part. I wish I had one in front of me right now. You could check out that video, and like I said, it kind of explains the whole process on that. So to answer your question, it's not sort of piecemeally. We don't just train you on one machine in particular. It'll be all the machines, and then you have full access to the facilities.
And if I can kind of add in on that, kind of elaborate on Jacob's, the staff are here, full time. So, and probably one of the, well, I will say the absolute best aspect of this shop, besides having all the cool tools and machine tools, is the technical staff. They're very much mentor-minded, a lot of years of experience. We have very diverse backgrounds, and we work off each other's kind of strengths. So you get this 5 hours of safety orientation. And as I kiddingly say, usually your project, when you come back in to do a project, it doesn't ever look like the widget. So there's always a lot of questions. And this is one of the things that I'm very proud of our technical staff, is they're very welcoming and have the time to, kind of walk you through the project and answer your questions. So we've had many, many students say that this has been one of the highlights of their experiences, the time they spend in our student shop.
Anything else you'd like to add, Scott?
If there's something, I was just reading through
reading through them too. Jackson was asking, how often do classes have projects that we can use the shop for? I would probably say, unless somebody's going to correct me on this one, that class projects are going to be primarily for your upper division coursework. So junior and senior year is when you're going to start getting into some of those courses. Just to name a few off the top of my head, that'd be ME102B, a mechatronics course. ME135 is another course. ME103, ME107. Scott, you could probably chime in and name more than twice as much as I can.
Yeah. But kind of, I think everybody gets the idea that it's primarily junior and senior. The one thing that is coming down the pipe, and that's Professor Taylor mentioned this transition from E27 to E29. We're in the and this is going to probably be second semester sophomore in the curriculum, and we are working towards making that kind of our threshold class to where you can actually get in and get the training and have access to the shop. On the next question, it says, is the shop reserved for classes only? The answer is no. Primarily our class projects are our first priority. However, we do support some research, and we also support a lot of the student club activities. So like Formula SAE, super mileage vehicle, solar car, the rocket team, Hyperloop. I mean, it goes on and on. Those typically are good gateways for a freshman, is to join one of those teams and get vested with them. And then they submit lists of students every semester for us to be candidates to get trained and have shop access. And I got to say that I personally think that that's a stellar threshold, or way to get into the shop early. You'll get a lot of experience, a lot of mentoring from upperclassmen while you're working on these various student projects. And I see a big difference in kind of the development of our students that go through one of these student courses. That's given you get the time and kind of the perseverance to stay with it.
I will add to that because Aiden was asking about how can freshmen get access to the machinery. So we've mentioned basically 2 organizations that you can belong to that'll get you shop access, and that would be class projects, and that would also be these extracurricular team-based organizations. The third avenue that you can get in through is by joining a research lab that you would need to fabricate components for. And so if you belong to any one of those 3, if you were a freshman and you were really kind of wanting to get in there and get access to the shop and manufacture components for a laboratory, that's another way that you can get in, is by joining a research group.
I also do want to mention that on the curriculum flowchart, it shows E29 as a fall course for your 3rd semester, which is your sophomore year, as Scott was mentioning. However, folks that have E26 under their belt will also be prepared to take E29 in the spring semester as well too. So we definitely anticipate that there will be a lot of first-year students that will be in E29 this upcoming spring.
So William asks about how much does it cost to use the machines. The question is more, are you asking about who pays for it, the taxpayer or you as a student? Well, the students, it's actually free. So the access to our facilities, Scott has really tried to drive that students don't pay for access here. What we require students pay for is their materials themselves. So if they're going to be doing a student project, they need to be able to provide their own materials. But when it comes to actually using equipment and the machinery that you see here, the tooling and everything else, that's all provided to you. So I guess the answer is free of charge for the most part, with the exception of course, your materials.
I have a question. This is a question that comes up often, but what about personal projects? Are you allowed to engage in a startup and run it through the shop?
Good job, Ricky. All right. There's always that question. Unfortunately, being that we are supported by mechanical engineering and they do pay the bill, our mission is pretty clear that it has to be academia. So unfortunately, we really dissuade people from, personal projects and doing startups. There are other resources on and off campus that we can point you to for that type of situation.
What about making a keychain for your mom that's listening at home right now?
Yeah, it's ideally sometimes you got to catch us at the right time. If it's, and how good of an art, how well can you convince us? But typically we really try to avoid it, because if we focus on that one kind of freebie that's not academically related, that means that there might be 2 or 3 other people on the shop that need our help that we're not focusing on. So it's really kind of a courtesy to everybody else in the shop that we avoid that.
I will kind of add to that. While Echeverry is the home of mechanical engineering, is a couple of other departments. One of our neighbors, Jacobs Hall actually has a maker space where you can go and make things, especially personal projects. Theirs is set up a little bit differently. You have to buy materials, and then you also have to buy basically a maker pass. So I forget who asked this question. William asked about, how much does it cost to use a machine? So I think that you pay a flat fee, and for that flat fee, you get access to all of the equipment for the semester. And their training is set up a little bit differently. It is much more piecemeally, like I think William was asking about earlier. So you get trained on individual machines, and then you can use those machines. So I'll link to that below if you're interested. And again, this place, Jacobs Hall, allows personal projects, class projects, and pretty much everything under the sun. So I'll include that link in the description, and yeah, you guys can refer to that. Aiden was asking about, is there an avenue to purchase materials through the shop? So we don't actually really have a whole lot of space to be holding on to all the different sort of materials that you'd want to have. We have a selection of it, but we really don't sell to students. We can give you a smaller piece of material, if it's for a small little project, but if it's beyond a certain threshold, we're going to have to, basically have you go and get it. So we have a list of preferred online and local vendors as well that we can provide to you. But if it's for a big project, you're probably going to have to make a run out, locally or just order it online. Again, one last thing, you can order materials through Jacobs Hall. They have a materials store where you can purchase things like commonly used materials like acrylic, plywood, aluminum, steel plate, and things like that, and have it shipped to Jacobs Hall and pay for it through them. And I believe that the billing is very similar to, I think it's just a credit card, but I could be mistaken. So check that out if you're interested. And Aiden, if you're interested, I can get that link for you, the Jacobs Hall material store as well.
If I can just add upon that just slightly, another reason that we typically don't sell materials, like Jacob touched upon, is that there's a wide array, but also, we recognize that you are going to be engineers, and so developing bills of materials, specing materials, instead of us just going, here's a piece of material that's good enough, you're relying on us, where really as engineers, that's some of the critical decisions you should make, and it's good practice to, kind of go out and do that. So just kind of one of my own personal things.
Scott and Jacob, I wanted to ask about, we threw out a lot of different courses earlier, and for new students, that might sound a little bit like a foreign language in terms of us just naming off a few courses. Could you just, one of the big ones though is 102B, which really is like a culmination of the student experience, where they're combining multiple skill sets into one, in order to present at an inventor space, the invention lab, which we call Hesse Hall. Can you describe what that experience is like and some of the most unique and fun projects that you've come across throughout your time?
Jacob, you want to take a stab at it?
I was going to have you kind of scope
Okay.
this one out.
Okay. All right. So ME 102 is actually been around in our department for many years. It's really a capstone project class, but unlike a lot of universities that will give you a prescribed, you need to make this part, and then they really kind of lock you into a particular theme. Here at Berkeley, we take much more of an approach of to stimulate your curiosity and your creativity. That we don't put that type of threshold on you. It's a mechatronics course, so it has to have an embedded microprocessor, and from there it's pretty much ideally you want to keep it to a meter cubed in size, and other than those two parameters, you're pretty much off to whatever you want. We've had the startup for like the Mars rover. They started their first couple iterations of their project through 102B. A few years ago, I'll make this a real quick story, but when the new Star Wars movies came out, and one of the characters was that character BB-8. One of those groups came to us and said, "Oh, we want to build a BB-8," and it was quite challenging, but they actually pulled it off. It was just absolutely impressed us at the elegance of the to the point where they wanted to, when they got their degree and walked on stage, they were trying to figure out how they could get BB-8 to go on stage with them to help them accept their degree. Unfortunately, administration wasn't real fond of that idea, but I was all for it. I thought it was going to be too cool. But just the beauty of 102B is again, it's pretty wide open. So if you have a particular passion, it's it's music, it's electronics, it's science fiction, it's whatever, it really, you can play to it.
One of my favorite projects was the liquid cooled helmet that I saw, and also last year, what was really amazing was the record player that was built from driftwood that was found on the side of the road. A real ecological project brought to life, which was really nice to see.
Yep.
All right. Well, it looks like we're going to be transitioning into our student panel, which a lot of the folks have been waiting for. I'm really grateful for Scott's expertise, for coming in and sharing, for Jacob, for really just putting together the video. I know we had a bit of issues with it, but we do have an uninterrupted version on our website that's now up that you'll be able to watch. Ultimately, extremely grateful for you two, for all the work that you do, for all the guidance that you provide for our students. On a consistent basis, when I'm in session with students, they'll just be raving about how great these two individuals are. So I'm so thankful that I get to work alongside them, and thank you for sharing your time with us today.
Oh, thank you. And Ricky, can I do the traditional thing?
Yes.
Go Bears.
Yes, of course.
Everybody's going to get tired of that by the time we get through with this.
I think it keeps all our spirits up. One thing that I love about being a Berkeley alum is that wherever I am in the world, if someone's wearing a Cal shirt or a Cal hat, if you go bear them, they usually go bear you back. And
Yep.
if they don't, then they're just, it's like their cousin's T-shirt or something,
Yeah, I was actually in France a couple years ago, and I got a couple of those. It was pretty awesome.
Yeah.
I was just waiting to hear it in French, so.
All right. Well, we're going to be transitioning to our student panel. Our student panel right now is currently sitting in the audience. And we'll take a bit of a break. I'd like to ask our audience to just close your eyes for 10 seconds as I want to help out a little bit with just a little bit of screen fatigue. So let's just do this 10-second exercise of just closing our eyes real quickly and take a deep breath, everyone. All right. So
Okay.
right now I'll say goodbye to Scott and Jacob, and thank you so much for joining us.
Thank you, Ricky. Thank you, Jacob.
All right, so we're approaching the 1 o'clock mark, which is when our student panel is scheduled to join us. Right now, they haven't requested to join the screen, so they're not quite here yet. Please use this time, of course, to take a bio break if you need one, and just relax for a little bit, since being in session for 3 hours can be a little tiring. So, we got Franny in the house. All right. Franny just joined us. We'll start in 5 minutes.
You can't see me though, can you?
Not at the moment.
Okay, let me get on that.
All right, we also have Michael Nash in. And while we're waiting, I'm going to put up our flow chart just in case anybody has any questions that I can answer before we get started at 1 p.m.
Yeah. Hey, Ricky, can you hear me?
Yes, I can hear you.
Can you hear me, Ricky?
Yes, I can. Thank you for joining us.
Can you see me now? Right?
Yes, I can see you.
Sweet.
And for those of you who might have left and are just joining us, we'll be starting at 1 p.m. We have a group of some exceptionally great panelists that are here to give you some insight, some ground level experiential wisdom of what it was like to be an ME student at the #1 public university in the universe. Michael, how are you doing? Do you need your, how's your video going?
I'm doing good. Can you hear me?
Okay. Yeah, sounds good.
Yeah.
All right, so in about a minute, I'm going to be introducing everybody. Everybody just hang tight. All right, let's get this show on the road. All right, so first I'd like to introduce Franny. Franny Barthel has graduated Berkeley with a bachelor's degree in mechanical engineering in the spring of 2020. She's now becoming a fifth-year master's student and is focused in control. Her experience is mostly in the aerospace sector, but she hopes to, in the future, that she can apply her engineering education to environmental engineering to help fight climate change. Franny loves ocean swimming, cooking with all her friends. She loves to run, pretty much anything that happens outside. She's super excited to jump in and start working on her master's, but above all, she's excited to be a mom one day. Her best piece of advice to incoming students is to not make engineering your whole entire life while you're here at Cal. Get out there, have some fun, and love all your friends. Next, we have Michael Nash. Michael Nash is a senior expected to graduate in the spring. He's from Auburn, who transferred from Sierra College. In his free time, he rides mountain bikes, and he doesn't just ride. He's actually a professional mountain biker, from what I remember reading. He's currently a student assistant at the Lawrence Berkeley National Lab. He helps design radiation shielding for the Advanced Light Source, and he plans to get his master's degree after graduation and then go into industry. Lastly, we have Alex Zapata. Alex graduated last May with a degree in mechanical engineering. He's originally from Southern California, and he transferred from Mount San Antonio College in 2017. During his time at Berkeley, Alex was a member of the Space Technologies at Cal, the Helms Research Group at the Lawrence Berkeley National Lab, and the Combustion Fire Processing Lab with Dr. Fernandez-Peyo. He interned at SpaceX, at JPL during his time at school, and he's currently working full-time at JPL. For those that don't know what JPL is, that's the Jet Propulsion Laboratory. And there he's working on their environments and mechanical reliability group. He's planning to pursue a master's degree in astronautical engineering at USC next year. So we got a lot of talent in the house, and it is my absolute joy and honor. This is the best part of my job, is interacting with students. And we'll start with the lead question, and then hopefully folks will start asking questions in the audience. Now that everybody's shaking off their nerves a little bit, please come on camera. Please request to speak. We're more than happy to see you and hear you ask your question live. So please just ask your question live if you can and if you're willing. But we'll also be taking questions from the chat. So we'll start with a team question. Berkeley has a bit of a competitive edge. Sometimes there's this folklore that exists about Berkeley before you even arrive on campus, is that Berkeley's this quote unquote cutthroat institution. And for me, it's always important for me to talk to our students about this, because these are just mythologies that keep recreating themselves from one year to the next. And I think it's important for us to talk about how we collaborate and work with one another. So for our panelists, what are ways that you've worked in teams to accomplish common goals in the classroom, and how has that been beneficial to your overall success?
First.
Yeah,
oh.
go ahead.
Go ahead.
Okay. I think this is kind of a short answer, but one of the most helpful things for me when I was studying or just learning the new material with people was understanding that the best way I learned it was to teach my friends, and to even teach people that weren't my friends, like anyone that asked for help. Don't be afraid to give help, because you're helping your students learn. That's what we're all here to do. And second of all, the yourself is by explaining it to someone else. Like, it's actually an opportunity for you to be a team with this person, and one day they're most definitely going to help you, because we all need help. But it's actually one of the best ways I've found to engage with the material you learn in the courses, and kind of like be a teammate to your friend.
Is there anything any of the other panelists would like to add? All right, we'll take a question from Martin, who's in the audience. So Martin, let's bring you on screen. I just added you. I'm not sure where you went. I'm here. All right. I don't know why you can't come on screen. Oh, there you are. All right. Yes, Martin.
Hello. So I'm very excited about my journey, and thank you everyone for being here. So for my beginning, I'm interested in going to graduate school for PhD. So from what I heard from everyone, that I should be focusing more on research labs, getting this type of opportunities, and trying to get some papers and publications. However, I feel honestly kind of lost how to begin. I feel there are too many ways and too many directions to go, and I'm not really sure what is the optimal direction to take, especially that as a transfer student, I don't have that much time to explore, so I can't mess up my chances. Do you have kind of any guidance? How should I begin, or what is the direction I should take at the beginning at least?
I don't think we can hear you, Alex.
Yeah.
I was able to hear him. Were other people not able to hear him? His question?
Oh, I wasn't able to.
We're able to
I
hear
heard Martin.
Martin. Yeah, but
Yeah.
not Alex.
Oh, okay. Okay.
I have an answer. When I started here last year, I was a transfer student as well. What I chose to do was take an internship instead of doing research because I'm a little bit more focused on going into industry. But I would say wait until you actually have classes and get to know your professors, because your professors will be the ones who can get you into one of these undergraduate research groups. And keep in mind that some of them might not include pay. You might have to give up a lot of time during the semester and possibly your summer. But if you want to go into the PhD route, I definitely suggest you do that and get signed up with somebody in the fall.
I also want to comment that there are different programs that exist that help students acquire research positions by equipping them with the tools. So, for example, there's the McNair Scholars Program that gives students, the training that they need in order to develop a research proposal, in order to be able to, get their hands dirty and their feet wet on, the ins and outs and the nuances of conducting research. I think that once you get that training, it allows you to be a little bit more marketable as well while you're communicating with faculty. So I definitely recommend different programs like the McNair Scholars Program. I also recommend going on research.berkeley.edu, which will provide you with a lot of different resources on how to develop proposals, how to work with like human subjects, just the different ins and outs. There's also good tips at research.berkeley.edu around, how to communicate with faculty and how to be persistent and give, put your best foot forward in terms of building the communication that you need in order to gain, the valuable communication skills that you need in order for you to land a different research opportunity. I would start by going and observing our major field areas on our website at me.berkeley.edu. Click on people, click on faculty, click on their major field areas, and just start exploring the different possibilities. Now, there's different faculty that are doing things like, for example, they're doing things in fluids, like through the Flow Lab, but they still need somebody who can do programming. And you might have that skill set, and you might think like, well, I'm not really interested in fluids, but, I have this skill set in programming. You might not necessarily know by reading that. So, it's really important for you to ask. There's also graduate students who teach courses that you could also have set up informational meetings with. And I think that that's also an important, social capital that you can build by communicating and accessing them as well. So there's like you said, there's multiple ways, but just chip at one by one. Just do something that, first spend some time reflecting and figuring out like what type of research you actually want to do, and then start narrowing in on like the different people who are experts in that area and try to get as much guidance as you can from them. Sometimes just like learning from different people's labs, you start to ask the relevant and curious driven questions that'll allow you to open up more opportunities for yourself. We have another question in the chat. Martin, I'm gonna take you off, but if you have another question, feel free to come back on, okay?
Thank you so much.
No problem. There's a question as to why did you choose to attend Berkeley since UCB doesn't have Aero, and what led you to go into Aero? I think this question's for Franny.
Yes. So I have experience in aerospace. I specifically mean I've been able to do 2 internships during my time at Cal. They were both just summer long, and they were both in aerospace. The one was with a small startup called Astra Space in Alameda, and then the second one was with Virgin Orbit. And in the meantime, I actually got involved with a fellowship called the Brooke Owens Fellowship, which if you're a non-male identifying person interested in aerospace, you should definitely check that out. It's a really awesome fellowship. So aerospace just kind of happened to be the internships that I got accepted to, and then I got that fellowship. So it kind of kept going in that direction, and I was like exploring aerospace, but it kind of just like happened that way. I think especially at the beginning, I was just eager to get an internship like a lot of people are. And then I think having those two experiences in aerospace, even though they were both really wonderful, has made me want to try something else. So I didn't even come to Berkeley knowing I wanted to do anything with aerospace. So it wasn't like it didn't put me off that it didn't have aerospace, because I didn't even know that I would want to do something with that coming in. I hope that answers the question. But the fellowship is called the Brooke Owens Fellowship. If you have any interest in space, I would really encourage you to check it out.
Yeah, I think programs like that are really valuable in terms of creating access points for different people, especially non-identifying males who are very much needed in this field. I must say that mechanical engineering is by all means like the territory of like the aerospace industry. A good amount of our students like have gone on to work for NASA, or even become astronauts and log in tons of space hours. So you do get the training that is definitely valuable and that will prepare you to succeed in aerospace. To add to that, we're also have an aerospace minor, as we mentioned earlier. We're going to take a question from somebody who wants to come on screen, and then we'll transition over to the other chat questions. I think it takes a little bit of time, but they're on their way. You probably have to like fly through the virtual
Yeah,
world.
it's a pretty dramatic entrance.
How's it going?
Good afternoon.
Yeah, good afternoon. My name is Jonathan. I'm a freshman, so this is my first year. And I was just wondering about like internships and stuff. When do you start? Like what year should that, or should I be like already searching? Because I don't feel like I have the skill sets really to work for any internships or anything yet. So I was wondering when you should do that.
So I started pretty early from junior college. I think typically at junior colleges, we have more of an emphasis on getting an internship because sometimes, you don't know which school you're going to go to. It might be harder to get a job. The way I did it was I applied for a government internship called SULI. It's through the Department of Energy, where you can basically go and work for a summer. It's a paid internship, and you can pick basically any field and work at any of the Department of Energy national labs. I chose the Berkeley lab because, I was going to UC Berkeley and everything. And that's what led to my current internship that I do through the school year and throughout the summer now. But yeah, in my opinion, you should start now, start looking for next summer. The only limiting thing is if you have to take summer classes to catch up or something like that, always put school first. But, it's never too early to start.
Okay, cool. Thank you.
I would just add to that, I did not do an internship the summer after my freshman year. I was like a lifeguard and I took summer classes. So I totally think that like it's especially it is great to have internships, but I think especially what I think is like in your first summer, if you find something that really excites you and is awesome, totally go for it, but don't kill yourself and feeling like you need to have an internship every single summer. Especially, like maybe it's something that if you go into it knowing that it's not going to bring you anything, you're not going to enjoy it. I personally think that might not be like the most worthwhile thing to do, especially because like you were saying, like right now you don't have as many skill sets, or you haven't learned as much that you can kind of advertise to people hiring. And so really the more juicy internships that you could get will probably come like next year or the year after that. So if there was ever a summer where you wouldn't take an internship, where you might just want to like earn more money or just like be with your family, then I would say that should be your first summer. So I think like if you find something that's really cool, you should do that. But I think there's a lot of pressure on new freshmen coming in to get an internship right away. And you know, it doesn't always work out that way. So I wouldn't worry too much, as long as you like hopefully get 1 or 2 in there along your 4 years at some point, is what I would say.
Okay, cool. Yeah, thank you. And I also have one more question, which was, do like joining clubs and stuff help you get these internships and things? Like if they see that you're like part of different clubs and different like things like that, then will they like take that into consideration and stuff?
Absolutely. I mean, 100%. I think there's probably no better way to get an internship at a really good company. You know, for example, my buddy who joined the Formula SAE team, before he even got to the next summer, connections at SpaceX, and went and did an internship there this summer, which was actually interesting because they were one of the only companies actually doing in-person internships. So yeah, if you want to join a team, definitely go for it. That's a really good way to get your foot in the door in some of these industries.
Yeah, I think that one thing that's really awesome about our department and our student organizations is that there's so much more to them than just being clubs. You know, they really are build teams. They in many ways they're compatible with industry standards in terms of the type of machines that they're building. And I think that you know, like Mike said earlier, like you know, having that proximity to industry by being part of a student organization is really important. You get that because our students are so talented that industries are consistently looking you know, at our department, at our student organizations, and seeing what they're doing, because at many times they're really pushing the edge of innovation, and industries want to be part of that, and they want to be a part of it while you're actually in school. So one thing that I love about you know, our department is that you are gaining a really strong and practical skill set from day one.
All right, cool. Thank you guys. That helped a lot. That was all my questions.
Thank you, Jonathan. I appreciate you coming on. McDolly had a question, I think, for Franny.
They were just asking if I have contact info, so I just put my Berkeley email in there. I hope that's okay.
Yeah.
I think there was a question up at the top about the best way to get internships, but maybe we kind of addressed that. Just like.
All right. We have another brave soul that wants to come on, which is Sebastian, and they'll be on soon. Oh, he was on a lot quicker.
Hi, my name's Sebastian. I'm a freshman or incoming freshman, I guess now. And I had 2 questions. One was, is it helpful to build almost like a portfolio that would demonstrate either your like CAD design skills or like programming skills as far as like applying for internships, or is it more that like they just want to see maybe like the actual class that you've taken on your resume, or that you're proficient in, you know, some program or some language on your resume? That was my first question. And also my second one's a little bit kind of for Michael, but I'm also a mountain biker. My bike's there for the moment because the bike storage only opened today. And I was wondering if there were any like student run clubs on at Berkeley that like pertain to bike design or something like that, because that's something I'm also interested in maybe for after college.
Yeah, so you had 2 questions. The first question was about a portfolio, and you know, coming from a junior college, we're super heavy on getting a job at the end of this. And in my opinion, when you graduate, everyone has a bachelor's degree. So you have to have something that's going to set yourself apart from other candidates. It's a good bachelor's degree. This is one of the best schools, and people take that into consideration when thinking about what kind of skills you already have and stuff like that. But, for example, I definitely have a portfolio. I have, reports that I've written. I have things that I've designed, CAD work that I've done. And I don't necessarily give it on every application, but it's good once you find a point of contact, just to kind of dump a lot of your qualifications onto them, send them an email with just your whole portfolio. And that way they kind of get to know what you're about, what they can expect from you if they do choose to hire you. I hope that answers that question. The second question, I recognize that bike. It's a One Ghost. My brother actually has that same bike. And yeah, Cal has a cycling team, and you can actually join and compete in collegiate mountain bike racing. They have cross country, they have enduro. I believe you can race downhill. I'm not sure. But yeah, I was going to join the team this fall. Unfortunately, COVID happened, so I probably won't be able to join the team. But yeah, check out Cal Cycling. And they also do group rides and stuff. So, if you're bored and you just want to get out and exercise, you can go ride with them.
Thanks, guys.
All right. Thank you, Sebastian. All right. We got Alex back.
Yeah, sorry about that. I have some technical difficulties, but I'm back on.
It's all good. Maybe you could take the next question. It was for Franny, but she's been answering a lot of them. Okay. It has to do with, how do you secure an aerospace internship specifically? I kind of alluded earlier that, mechanical engineering does equip you with a really strong foundational skill set to be marketable in the aerospace engineering. But maybe you could take that question.
Yeah. So so that was a major concern of mine, because I knew when I transferred, I wanted to focus on aerospace in particular. But as this person probably already knows, there's no aerospace major here. Although when I was graduating, I did hear that there is now an aerospace focus. I'm not really too aware of that, but at least in my time, I didn't know about it. So I would say definitely get involved in extracurriculars that are aerospace focused. There's a lot of clubs on campus that have different focuses and interests. I was part of Cal Star when I first came. It was a rocketry club. And then I was part of STAC, Space Technologies at Cal, where I was working on CubeSats. If you want to get more into airplanes and aeronautics, you can do Aero SAE. So there's a bunch of different paths that you can go depending on the focus you want. So you'll have to just reach out, in my opinion, further than the classroom. And that's definitely a good way to get that specific kind of experience, to kind of get your foot in the door for an internship in that field. So when you have a recruiter talking to you about what it is that you do, or how your experience could be related to this internship you're applying for, whether it's like Boeing or Northrop or Lockheed, SpaceX, somewhere like that, you definitely want to show them something beyond just like your ME workload. You want to show them like, hey, I have these interests and I do Aero SAE and I help design, the fuselage and these wings and the landing gear, whatever it is. So definitely having that extra little bit would help you a lot.
All right, I'm gonna lighten it up a little bit and ask a question myself, and then we'll go back to the other questions that students have. But let's talk about housing a little bit. What's it like on campus? What was your experience like with housing? How does housing and the social and psychological choices you make around housing impact your academics?
I could start that one, and then we could all talk about it. So for me, mine was a bit of a risk when I transferred. For transfer students, is different. We don't really have priority in getting housing from the school. You have to pretty much go by your own means, whether it's Facebook Marketplace, There's a housing group on Facebook. I highly recommend utilizing that, or Craigslist, whatever it is, to find an apartment. But I actually ended up moving in with some random people that I had met on Facebook, and it was a super, super big gamble, but they ended up being some of my best friends that I still hang out with now and talk to now. And so you definitely want to surround yourself with people that will provide you a good amount of support. I don't know if I would recommend, living with a bunch of people who are only engineers. I did do that my last 2 years, which is completely fine. We're all best friends, but it's kind of hard to escape, the work that you do in school when you come home and it's just everything's engineering focused. But definitely, moving in with people that can provide you emotional support, give you space when you need space, and don't be afraid to explore outside of just what the school provides, dorms. And I think they have like some transfer dorms, or like some dorms like for upperclassmen. Definitely go through Facebook, talk to friends, see what's out there. And I know there's a housing shortage. Although right now with COVID, I don't know how much of a problem that is. I think a lot of people are going to be staying home. But yeah, definitely try to surround yourself with good people, and yeah, branch out in different avenues: Facebook, Craigslist, student housing, whatever.
I would definitely echo what Alex said about don't feel like you have to live with a bunch of engineers. I never lived with engineers, actually. Well, I am now as a master's student, but it was really nice to actually get to kind of leave school at school a little bit. I mean, you still have to study at home and stuff, but you're learning about what your peers are doing, and your roommates are doing, and if they're taking some cool class that maybe you can take on the side or something. Yeah, there's going to be a lot of engineering talk in your day, just all your classes and the engineering kids you're learning with. I personally really enjoyed not having that follow me home so much. Yeah, just hopefully find people that can make your home feel like a home, and that you can feel like you relax when you come home. I think it's hugely important to have a home that feels comfortable. And a big piece of advice I would give is, if it doesn't feel that way, if you find yourself in a situation where you don't get to relax when you come home, you feel like you actually have to escape your house, try to look for new housing. Don't feel like you have to be stuck in that for 4 years. Try to figure out a way for someone to somehow get out of that situation, because I think that's huge. And if you have that burden for that long that your home doesn't feel comfortable, it's going to really take a toll on your social life, on your school, on everything.
All right.
Just like to add one thing. As the logistics go, if you're looking for a place off campus, be very cognizant that a mile in Berkeley is a lot farther than probably a mile where you're from. I live about a mile from campus, and I still actually drive a few blocks. And depending on where you are, you might have to walk up or down a big hill. So if you're looking on campus, definitely try to get as close as possible.
I definitely agree with that. I think I lived in a lot of different type of places when I was on campus. I lived in co-ops, I lived in dorms, I lived in apartments. I definitely recommend living in Rochdale Village, if folks have ever heard of that. That's one of the co-ops. It's one of the apartments where you get your own room. It's nice because you still have a community of that you get to engage with in the living room. You do a few hours to kind of engage with the setting, maybe some gardening, to do some hours to reduce your rent, maybe some recycling, but at the same time, you also get your own room. And but also, I just want to say that being part of, your living space is absolutely important in terms of just setting healthy boundaries. So I think one thing that I appreciated about the people that I lived with was that, if I wanted to go study, there wasn't this this temptation to bring you in and kind of get you to socialize with them. because you do find that type of pressure when you're in college, right? So folks, the more you can set up healthy boundaries, the better it can be for folks. So we'll move on to one of the questions that somebody asked in the chat. We obviously have 2 students that are going to be starting their master's program. Michael's thinking about it. Somebody mentioned that they're not really necessarily interested in pursuing a master's degree right after school, but we're wondering whether pursuing research or an internship really matters in terms of getting that job once you graduate. And I'll start off just by mentioning that, if you have a research opportunity and you want to engage with it, it still will be valuable to an employer. I think that the skills that you gain as a researcher are skills that are transferable and compatible, and sometimes it'll be directly with what they're looking for. But I think that both experiences are comparable to preparing you for the next step.
Yeah, I agree with you, Ricky. Definitely, both are really good. Anything beyond just your regular classes is going to help you. And I think to add on, not just research and internship experience, but also like club experience. Anything that shows that you have some initiative in, pursuing some kind of field or some kind of area of focus that you're interested in is definitely going to look good to an employer. I had, for my own personal experience, I had a combination. I did some research and I did some internships. But the research I did wasn't really focused or related to what I'm doing now. The research I did it for a number of reasons. One, to diversify my portfolio and my resume, because I think at the early point in time when I first transferred to Berkeley, I wasn't exactly sure what it is I was going to be doing. So I was working in a bunch of different labs and doing a bunch of different things. But I started really honing in on what I wanted to do when I joined CalSTAR and STAC. And those were, in my first few interviews, those were the main talking points. What did you do in this club? What have you learned? Here's a technical question related to, rocketry. So I would say, if you know where you want to be and what kind of work you want to be doing after you graduate, find something on campus that is slightly related to it and start pursuing it that way. And that way, when career fairs come up and you talk to employers and recruiters, you show them, you say, hey, I'm super interested in this. And I started, working on this subset in this club. And, I think I could bring this to the table. And, definitely show that you have some initiative. That'll be a good way to give yourself a better chance in employment after graduation.
I would add on to what Alex is saying, in that a lot of times it's not even so much the actual work that you did in the research, sorry, this is the notification. Did I mute that? Okay. Not so much like the actual work a lot of times, because a lot of times people who are hiring, they know they're going to have to train you. They know you're just a college grad. You probably don't know that much. You probably don't have that much experience. And, you could only do so many things. There's no way that you did exactly what they're going to need in the job or the internship, but highlight like how you were a leader, highlight how you managed a lot of different things. Like Alex said, how you showed initiative, how you had your own ideas, how you were invested. Things like that a lot of times are really meaningful to people who are hiring, how you were creative in solving a problem. They know that your research isn't going to be exactly what you're going to be doing there. They just want to know how you think. They want to know that you're trainable, that you can work in a team is hugely important, that you can manage responsibility. So I think highlighting a lot of those things is equally, if not maybe more important, I would say, than the actual like engineering things that you've mastered, but probably like about the same.
I also want to maybe use this opportunity to share someone's portfolio. This is a student who said she was fine with me sharing her portfolio specifically for these types of purposes. So I just want to share it really quickly and do a quick screen share. There's also another student who has a website. So I'll show you 2 different portfolios just so that you all have a sense of what they look like. Does that look small for everyone? Does that look too small?
If you double click it, you can maximize it.
I think I'll have to zoom in too, because I've already maximized it, but let me do a zoom in. There you go. Better? So this was a bit her intro. She describes just like a quick version of what she's about herself. She's interested in improving the quality of life, very mission driven, and then gives like some projects that she's worked on and some major highlights.
Hey, Ricky, could I answer a quick question in the chat that Alan had posted?
Yeah.
It's related to this. Yeah, so Alan,
Go ahead.
a portfolio definitely is, it could be a combination of your own personal projects too. Anything that you've worked on that you're proud of, definitely including your portfolio, not just something that's like name brand from a company, club, or research. Definitely anything you've done on your own, you can include.
Even sketches are included. Look at that.
I just want to mention, when you do send someone your portfolio, like, we talked about a sense of, who you are as a person, what they're going to get if they hire you. And oftentimes, people are most interested in the things that make you different from other people, like for me, I have a background in mountain bike racing and stuff, and that often comes up. And even though it doesn't have anything directly to do with mechanical engineering, it's often the thing that people are most interested in. So you definitely want to include that outside stuff and what makes you an individual.
I definitely agree with that. All right, I'll stop with this one. And then give you another perspective, which is Andy Myers. Is this big enough? He actually has a website which would link in his signature, and it would take you straight here. That's also a good thing too if you're talking to faculty and they just get curious and click on your link really quickly. They're able to see the different projects that you've worked on. Pizza slicer, I need one of those.
Also something I encourage people to do. I wish I had the prowess to be able to do this, but I've been seeing a lot more frequently YouTube channels for people in mechanical engineering, and they basically just use it as a project log, and that way, you get an extremely detailed report of your project and kind of your methodology when creating stuff. So, yeah.
Yeah, I would add to what Michael said. It's not my YouTube channel, but my 102B product is, some of it is documented on YouTube, like the demo of it. And so it's always, I've used it so much just to send to random people and show them what it is that we worked on.
They asked if you all have LinkedIns. It's a question from Alan.
Yes. here.
Yes.
I think we could. I think I linked it in my profile, but I guess we could just link it in here as well. Yeah, definitely make a
I actually
LinkedIn.
do not, but if
Oh, no?
someone wants to contact me, they can just email me directly. I feel that, you know, person-to-person contact is more beneficial for me.
Yeah, I would try to get yourself on any kind of platform to communicate with, you know, people in industry or even just, you know, colleagues. LinkedIn is pretty good. You know, it's kind of hit or miss. Like I do have a lot of coworkers who don't use LinkedIn. My boss doesn't use LinkedIn. But you know, there's a huge network out there, and you know, any way you can tap into that network, I say do it.
Yeah. I would say also too, if you have it, definitely maintain it. You know, it's something that is accessible to people. So if you don't maintain it, it also shows that you're not paying careful attention to detail. So once you put it out there, just make sure you're updating it. I know that for me personally, that I definitely intersected with that transitioning into ME. Like, you know, I was starting to have a lot more industry contacts. I was starting to develop an industry alliance program, and I just wanted to make sure that, you know, my LinkedIn was up to date. So I had to go in there and just, you know, not completely rebrand myself or anything like that, but really give myself you know, a refresh and a nice polish. So from time to time, you probably will have to do that and just stay up to date with that. All right. Any other brave souls out there who want to ask? We probably have time for, you know, 3 or 4 more questions. Anybody want to come on screen? Oh, that's a good question right here that just came through the chat. Preferred campus spot to study or do homework?
This is super subjective. Yeah, so there's a lot of places to study on campus. Some really popular ones are like Doe Library or Moffitt. I personally never really enjoyed those all that much. One, they can get either super loud, or 2, they're super quiet and you actually can't collaborate with others. The way that I found success at Berkeley was definitely in my study groups and people that I was working with. I mean, not to like burn my spot or anything, but we used to study a lot in Hesse Hall. It's you know, really does not look like much on the outside, but on the inside, super nice, high-rise a roof, lots of tables and comfy chairs and couches to sit on. Can get a little cramped if it does get packed up, but I find for the most part it's a good balance between, you know, collaboration, but also like it's not insane noise levels. That's a pretty good place. Anywhere on campus that you feel comfortable, you know, explore around and develop study groups, and you know, go around and explore the campus, see what fits for you. You know, we moved around all the time for the 3 years that I was there.
Franny, what's your favorite study spot?
By the end, it kind of changed like every 4 years. I think my freshman year, I was in Doe Library a lot because my classes were more just like cram the material into your brain. By the end, it was more like I need my friends' help, so we need to be somewhere where you can like talk about it. So I would go actually a lot to Hesse also. Hesse is always empty when everything else is full. I feel like I shouldn't put that out there, but it's true. Hesse is good. I also studied in like Yawley's Cafe. Like sometimes you kind of want that like chatty atmosphere. You're not like super locked in. I would also try to study outside. I wish Berkeley had more like tables and picnic tables and stuff, but sometimes when it's not windy, it's really nice to study outside. I personally don't like Moffitt. There's like a lot of people always there. So it does have study rooms though, which are always booked. But if you can book some, it can be really fun. If you like invite all your friends and you have like kind of a little study party for an hour or 2.
Yeah, Jacobs Hall also has study rooms that you could book as well. They're a little more limited, but I also like Jacobs when there's not a class in session. It's just a super nice modern building, and you could definitely get lost in there when you're working, which is nice.
I'd say one thing that is more of a guerrilla method is just like, you know, random empty classrooms on campus. You know, most folks like, don't really like pop their head in there. What's nice about it is if you keep it tidy and you're kind to the custodial staff, like you can eat there and without being bothered. And that's something that I always appreciated about being in school, is just like some place where like I don't have to like worry about like somebody tapping me on the shoulder and being like, hey, you can't eat here. But it does require like some relationship building with the custodial staff who like may want to kick you out like at 1 a.m. But people are kind. They know that you're studying. Sometimes they leave you alone. Sometimes they'll go to another classroom and let you be for a little bit. I must say I went to a presentation that was given by a neurologist, and she really said something that really hit home. I think that this is really appropriate to just say out loud, is that our mind makes neurological connections with different places that we associate with. Obviously, like if we're in a location that we associate with leisure, it's really hard for us to engage with like the concentration that we need. So, if being outside is a place that you associate with relaxing, taking time off from school, hiking or whatever, like really just consider that it might not be the best place for you to be studying. Same thing with Doe too. Like Doe is an incredibly beautiful library. It has the greatest collection west of the Mississippi, along with Main Stacks. It is such an awesome place to stare at. Like it's like a museum. But for me, it was never the best place to study because I was always just like, kind of like pumping my chest and feeling so happy and proud that I was at Berkeley, rather than actually like putting my head like on the sheet, So that's just something to think about. Another thing too is like just with studying in general, just be conscious of taking breaks, drinking lots of water, take care of yourself, physically and mentally, so that you can exercise your greatest muscle, which is your brain. So do all those things, think about those things. Don't just lock yourself in a room and try to like memorize as much as possible until you're tired because you think that that's what everybody else is doing, like putting themselves through misery. Like really set up learning as a way that you can actually like appreciate it, take the healthy breaks that you want so that you could really develop that flow where learning feels timeless, right? You really want to be, put yourself in the zone. And, everyone that's on this panel, I'm sure has experienced that where, you can spend hours doing, a project or working with classmates or doing homework where it feels really timeless because you're just absolutely in the zone and you're really enjoying it. And there's times where you're doing something where like, you're like staring at the clock and you can't believe like only 3 or 4 minutes have passed. But it does require like the psychological preparation. We had a question about how difficult do you think classes are than CC classes at Berkeley? And we have a good panelist to be able to answer that question, so I'll hand it over to them.
So yeah, in my experience, they were more difficult, definitely. Difficult just sounds like other harder classes. There's a lot more work required. You'll do fine if you got in. You'll do great here. But there's more work required. There's higher expectations in my experience. And I used to be very much like a lone wolf when I was in community college. I had 2 jobs and I would just kind of study alone, and I was able to get by. And when I came to Berkeley, it was a huge shock because I wasn't working anymore. Now I was being a student full time, and I needed help. Like it was a lot of work. So I definitely relied on a study group and developing a good network of people to work with. But yeah, the time commitment's gonna be there. You're definitely gonna load up, and not in a bad way. I didn't hate my time or anything, but it was definitely, every week there was a whole bunch of work to do. It was like a full-time job, and even then some, so there's definitely a big time commitment, and but I wouldn't say necessarily like harder. It's not like the material is, insane and you won't be able to comprehend. You will. You just put in the work, you put in the time, you study, and you'll be able to understand whatever it is that's thrown at you. Some concepts are harder for other people. Heat transfer wasn't too bad, but controls is notoriously is a pretty difficult class. Fluid dynamics, pretty tough class. So it just depends. Some people can breeze through them. Some people need a little bit of work. Some people struggle a little bit more. And you just definitely have to take it class by class. Work with people that that you trust and that you're comfortable with, and you'll do fine. You'll do good. Yeah, that was a long-winded answer, but yeah.
I just wanted to say that classes here are graded differently than they were for me at community college. For example, when I was at community college, if we had a class of 30 students and every single student got 100% on all the tests, we would all get A pluses. That's just not how it works here at Berkeley. Things are graded on statistics, and usually half the class is in the bottom half of the class. So I think it's really important to stay in contact with your classmates. Even if you are a lone wolf and you want to just read and study and do everything on your own, you absolutely have to keep in contact with people to know where the pace of the class is. And that's another reason why people say it's competitive here. Is because you are graded against your peers. How your grade ends up is stacked up with everyone else. So you can end up with a D points wise and still get a B plus or an A in the class. And then a lot of the times information for the class will be posted on either a Slack channel or Piazza or these other sources that aren't necessarily in lecture or on B courses. And you absolutely have to be checking those for updates, for corrections and assignments, and everything like that. So even if you are a kind of study by yourself person, you still have to make sure you are aware of what everyone else in the class is doing.
One thing that's not totally answering the question, but kind of on what we're talking about.
Yes, of course.
So kind of based on what these guys were saying, I was thinking another thing that can be really helpful, especially if you're coming, I can imagine if you're coming from a community college and you don't know anyone, this is also a great way to get to know people, but like office hours. And I saw Alex a lot at office hours and stuff. They're so good. You directly get to know from the professor what he's kind of expecting. You just get like a better idea. You might come with a question that because you don't understand something and he's like, don't worry about that. Or you just get kind of the best explanation you can. Also, it's hugely beneficial for the professor to know who you are, in my experience. I don't really know why or if it should be that way, but it's just awesome to have that relationship, for them to know your name, for them to know that you're putting in effort. Like, don't forget that in the end, they're the ones who are grading the papers. And, maybe when you're in like 1,000-person or 600-person classes, it's not as important, but especially when you get to the 100-person classes, it's just like huge to know your professor. And I think office hours are like a double whammy way to do that. You meet the other people in the class, you get the direct source, you get the info from the most direct source. The professor knows who you are. They know you're engaged and you're trying. Like, it's really important to them, actually. As someone who's not, I don't consider myself like a super quick learner or like a super smart person. I've always feel like I've had to work pretty hard a lot of times. Peers are, maybe I just feel that way, but I've always been someone who has to go to office hours and like extra help. It's hugely beneficial. So it's just a big thing I would recommend.
One thing to continue on what Franny was saying, if you want to get involved in research, go into office hours. All these professors, or majority, are doing research in some lab. So for the most part, all the stories that I've heard of how my friends got research is they just go to office hours. And aside from the questions they ask related to the course, they start asking them about their research and show they're interested and say, hey, you have an open position for an undergrad. So having that relationship prior is awesome. Networking, socially is super, super good, super beneficial.
Yeah, and I just wanted to say one more thing. This fall and most likely in the spring, you're all going to be taking online classes. And, the way that manifests itself is, you're taking classes over Zoom. And you individually all need to be responsible for participating in the class. And, in my opinion, you know, if you want the professor to get to know you, you have to have your video on. It's extremely crucial in my opinion. You know, don't be afraid to schedule a one-on-one Zoom meeting with the professor at the beginning of class just to introduce yourself, just so they know who you are. Because especially, I mean, in Berkeley in general, it's easy to get left behind. But with online classes, if you're just another one of those squares on the Zoom meeting and you're not saying anything and you're just randomly typing things into the chat, it's going to be a fundamentally different experience than video and actually talking with the professor.
And on that note, does anybody want to come on and ask one or two final questions? Definitely showing some appreciation on the chat, so we appreciate you all just joining us. I must say, like to Franny's point earlier about just getting to know our faculty and really engaging in the human interaction, you know, I think it's important. I think that like deep down inside, like our professors, our educators, they want to be able to monitor your progress and check in on whether or not they're being effective. And, you know, they've come across so many different types of learning styles and personalities. But if you give them, you know, if you prepare and you go to office hours and you show them that you're learning and that you're trying to intersect, you know, concepts that are coming at you in class, that show some consistency and some compatibility in your learning, they know that it's not a perfect system, especially when it comes to grading. So your effort is extremely important in terms of showcasing like what you can, like the different ways that you can succeed, and you facilitate your success and what you've been learning by being able to present yourself at office hours. And it's an incredibly valuable skill because when you're sitting in you know, a board meeting or a project room, when you're in industry, you're going to have to say out loud like what it is that you're working on, how those ideas are connecting with the other ideas that are in the room. And there's no better way to practice and to engage with that than doing it with professors, doing it with your classmates, and building one another up. So I think I'll probably leave on that note. I'm super thankful for the folks that decided to join us. I mean, we have people that are in high profile industry positions. We have folks that are in graduate school. We have Mike, who's an emerging senior and who's going to be there quite soon. And I'm just so lucky to be able to work with these students on a day-to-day basis. I just want you all to know that, you know, I'm an active listener. I'm somebody who will give you time, Please reach out to me, send me an email. I want to get to know everybody as much as possible. And my joy, my sense of fulfillment comes from watching you all grow and develop. So be persistent with me as well. You know, really set up a time to meet with me so that I can get to know you and you'll be on my radar. You know, I think that that's another part of the human interaction is that, you know, for example, you know, I think I did this with Mike too. Mike was telling me different things that he was interested in. I heard a presentation that Dr. Maki Harju was doing. You know, I sent it over his way and, you know, that was kind of compatible with his interests. So, you know, we help one another connect the dots, and the more I get to know you, the more I can connect you with our faculty. So use me as your home base, and I look forward to working with everyone. Thank you so much, Mike, Franny, and Alex. I really appreciate everything.
Hey, Ricky, can we just say one last thing? If there's anybody who has a question that wasn't answered here or anything, you know, feel free to message me on LinkedIn, or I can drop my email in here. Don't be overstressed. You guys are a super smart group of people for sure. So you'll do great. And as alumni, as current students, we're all here to help you guys out. So don't ever hesitate to reach out to the staff or to your colleagues. I'll put my email here.
Yeah, and this huge place, and sometimes it's hard to contact people, but every single time I've needed help with something and I can't get anyone, Ricky's always been there. So go to Ricky. He will respond to you. He will help you out. And if you can't contact me, just ask Ricky. He'll give you my contact information and all that stuff. Totally. Thanks, Ricky.
Thank you all. I appreciate all your support, all the love, and let's all get through this. Look forward to having a great year with you all.
Thanks, Ricky.
Thanks, Ricky.
Take care, everyone.
Bye, guys.